Hello my dear friends, welcome back to CSIR at home. In this video, we can study about vitamin K. Three forms, K1, K2 and K3. K1 is known as Phylloquinone. This is plant origin. K1, Phylloquinone. K2 is known as Menaquinone. And the third form is K3, that is Menadione. Menadione. This one is a synthetic. Okay, K3 is a synthetic. This vitamin K, that you know, it is a fat soluble vitamin. Vitamin K is a fat soluble vitamin, but Menadione, that is K3, is water soluble. So this is very important. Vitamin K is fat soluble, but the synthetic variety Menadione is water soluble. And this vitamin K is naphthoquinone derivatives. Naphthoquinone derivatives with long isoprenoid chain. Vitamin K are naphthoquinone derivatives with long isoprenoid chain. Vitamin K is getting from diet or intestinal bacterial synthesis. Okay, we get this vitamin K, the sources, that is, first is diet. We get this from diet, or the bacteria in our intestine can synthesize this vitamin K. What are the sources of vitamin K? That is green leafy vegetables. Cabbage, kale and spinach. These are important source of vitamin K. Green leafy vegetables are the important source of vitamin K. These are the rich sources of vitamin K. Next, we can study about absorption. Absorption occurs in intestine along with chylomicrons. Bile salts are also required for the absorption of vitamin K. And where this vitamin K is stored? This vitamin K is stored in liver. This vitamin K is stored in liver. Okay. Biochemical functions. Next, we can study what are the major biochemical functions of vitamin K. This vitamin K is necessary for coagulation. The blood clotting factors depend on vitamin K. Which are the factors depend on vitamin K? Factor 2, that is prothrombin. Factor 7, that is SPCA. Then factor 9, that is Christmas factor. Then factor 10, that is Stewart Pror factor. So these factors are dependent on vitamin K. Factor 2 prothrombin, factor 7 SPCA, factor 9 Christmas factor and factor 10 Stewart Pror factor. For the functioning of these blood clotting factors, vitamin K is must. These factors are synthesized by liver as inactive zymogens. That is, when these factors are synthesized, they are inactive. Inactive zymogens. These factors are synthesized. When these factors are synthesized, these are inactive zymogens. Then these factors must undergo post-translational modification. Post-translation modification, that is gamma carboxylation of glutamic acid residues. Post-translation modification, that is gamma carboxylation of glutamic acid residues. So first, these blood clotting factors are synthesized as inactive zymogens. Then they undergo post-translation modifications, that is gamma carboxylation of glutamic acid residues. And for this post-translation modification, that is for this process, vitamin K is needed. For which process? For the inactive zymogens become mature blood clotting factors, vitamin K is must. So, vitamin K is necessary for coagulation. Next, we can study in detail. First, these blood clotting factors are synthesized as precursor of clotting factor. Then they undergo post-translational modification to become mature clotting factors. For this process, vitamin K is needed, that we studied. Which form of vitamin K? That is reduced form of vitamin K is needed. Reduced form, that is known as hydroquinone. Hydroquinone form is needed for the conversion of inactive zymogens to active blood clotting factors. So, in this process, vitamin K, the reduced form is oxidized. It is known as oxidized epoxide. Vitamin K oxidized epoxide. Vitamin K oxidized epoxide. Then it reduced into hydroquinone. Which one? This oxidized epoxide reduced into hydroquinone. For this process, an enzyme is needed. That's the enzyme is epoxide reductase. Vitamin K epoxide reductase is needed for the conversion of oxidized epoxide into reduced form. Two anticoagulants, that is warfarin and dicomarol. Warfarin and dicomarol both inhibit this vitamin K epoxide reductase. This is very important, okay? Warfarin and dicomarol. These are anticoagulant. Warfarin and dicomarol inhibit epoxide reductase. Next function. Vitamin K is needed for the functional activity of osteocalcin. This is the another function of vitamin K. That is, this vitamin K is needed for the functional activity of osteocalcin. Osteocalcin. Okay, vitamin K is needed. What is osteocalcin? Osteocalcin is synthesized by osteoblast. And this is vitamin K dependent gamma carboxylation. This vitamin K dependent gamma carboxylation is necessary for the activity of osteocalcin. This vitamin K dependent gamma carboxylation necessary for the functional activity of osteocalcin. Osteocalcin is synthesized by osteoblast. And where it is present? This osteoblast is present in bone. Next, we can study about vitamin K deficiency. Vitamin K deficiency is not common because we know that this is synthesized from our intestinal bacteria. But if the bacterial population in our gut is reduced, how it is reduced? Prolonged antibiotic therapy. That is, if we are taking some antibiotics, what happens? The beneficial bacteria in our gut is also lost due to the continuous exposure of these antibiotics. Next is if we have some gastrointestinal infections with diarrhea. Okay, in these conditions, our gut bacteria is reduced, the load is reduced. That leads to deficiency. Antibiotic therapy, for example, cephalosporin inhibit vitamin K epoxide reductase. We have studied vitamin K epoxide reductase. Where it needed? for the conversion of hydroquinone, that is reduced form of vitamin K, this vitamin K epoxide reductase is needed. So cephalosporin, it's an antibiotic. It inhibits vitamin K epoxide reductase. Malabsorption of lipids. We have studied that this for absorption, chylomicrons are needed. So if lipids are not absorbed due to jaundice, this one is also lead to vitamin K deficiency. These are the conditions which lead to vitamin K deficiency: antibiotic therapy, gastrointestinal disease, and malabsorption of lipids. Newborns. How this vitamin K deficiency occurs in newborns? We know that the newborns, they have sterile intestine. That is, no bacteria in their intestine. So, they will have vitamin K deficiency. The disease is hemorrhagic disease. Hemorrhagic disease. Very low amount of vitamin K is present in breast milk. 15 milligram per liter. And what are the other deficiency diseases? That is post-traumatic bleeding, then internal bleeding, prolongation of prothrombin time and delayed clotting time. We have studied vitamin K is essential for the functioning of blood clotting functions. So if vitamin K is absent, it leads to prolongation of prothrombin time and delayed clotting time. Hypervitaminosis of K, hemolysis, hyperbilirubinemia, and brain damage. These are the diseases associated with hypervitaminosis. If you like this video, please subscribe and like and share. Thank you.